Welcome to Darkmatter everyone. Today we'll be making a 7-inch long range FPV freestyle build that will also be having autonomous capabilities. We'll be running ArduCopter for the firmware. Here we are at the Darkmatter website. Let us see what they have offering. And you can see the reviews are nice. So the Darkmatter is the India's very first flight stack manufacturer, including the FCs and the ESCs. So they have a nice lineup of F7 and F4 flight controllers with the 50 amperes ESC 8-bit. Wait, why does my PC require a restart? Let it be. We'll do it later. So here you can see that we have a very nice community. You can scan this QR code and join our WhatsApp community, where we have 100 helpful members to help you out in your FPV journey. So the components in this build will be using the Stack 450, which consists of the F4 flight controller and the 50 amp ESC. So we will be running ArduCopter. That's why we're using the F405 flight controller and not the F7. Because F405 is just better at processing the firmware for the autonomous capabilities. The stack features these components, including the capacitor, AMS 60 XC60 connector, a nice tin box. For the frame, we're using HDLRC Recon 7. It's a nice lightweight frame. Motor is the 1700 kV 2807 Emax Eco 2 series. The diversity receiver that we'll be using is made by iFlight. We're going to be using the one with the 2x220mm antennas. For telemetry radio, we have SICK telemetry V3. We'll be using the 100 milliwatt 915 MHz because the others were not available. We have a very nice affordable 1.6 watt VTX, analog VTX, that we'll be using for video transmission. And for the camera, we'll be using the Cadex Ratel 2. It's a really nice camera. It's affordable and just not. I mean, it's nice. Okay, so now we have the frame over here. I have already started some unpacking, and you can see the Darkmatter Stack in the frame as well. So in this video, most of the video is going to be in the time lapse. I will try to put as many comments as I can about what we're doing and how we're doing it, but it's pretty much self-explanatory. I'll also put a diagram over here somewhere, and then we can see what is happening, like what we're doing and what we're not. Right? Let me find a nice background music for you guys to listen to while you watch this time lapse. Alright. This is me trying to put together the frame, and what we see is okay, so there's a middle plate and a bottom plate in this frame, unlike some frames that have just a small bottom plate made out of aluminium. This is almost completely the carbon fiber frame, and the arms, they get sandwiched between the middle and the bottom plate, and you use some M4 nuts in this one to mount these two together, mount these three. So you can see the dry fit of the frame I'm trying to do. It is coming together nicely. There's two options for the VTX holders in this. One is for the O3 and another is for the analog one, and analog one was feeling quite right. We'll come back to that again later. So there's two different sizes of standoffs. One are a little bit longer, which go to on the front side of the frame, because that is the lower deck, and in the middle deck you use the smaller size standoffs. So there's like 6 small size standoffs and 2 larger longer standoffs which you'll be using. Always before you screw everything down, just make sure that it goes together, it fits nicely, snug. So it is really important that you do that. This is me trying to figure out what part that is, and yeah. Looks nice. So there's this small hole in these frames where you can put the capacitor. You can see how I've mounted the capacitor between the 2 pieces. This is me cutting off the capacitor legs, and so before I do any soldering on my ESCs, I like to put a tape on it so that any rogue solder balls do not drop on it. I took some time out of the video and I had mounted the motors, and I also soldered the XT60, but it's pretty fine. You can see me soldering the wires, the motor wires. So the key to a nice soldered motor wires is proper tinning of the wires as well as proper tinning of the pads, the soldering pads. As you can see, I've also added a heat shrink on top of the motor wires. It just looks neater, cleaner, and when you crash, there's not a lot of dust that goes into the motors, into the wires. So it just tends to stay cleaner for the rest of its life, and it's it's easier to route those wires if all of them are not individually hanging out here and there, unlike my previous builds, which you have no idea of. I'm also in the process of making a 5-inch. I have already ordered the parts. I'm still waiting for the Darkmatter guys to send me the stack. So once the stack is here, I'll make a build video for that. In that we will be flashing Betaflight, and we'll be flying it acro like I usually do. This one was more of an experiment of trying to get autonomous things going on with our F4 stack. The soldering iron I'm using is a local Ciron soldering iron, which is 65 watts, and another tool that I really I suggest people to get is the tweezers. It makes the soldering process very much easier because it's very hard to hold a very hot wire for a long time while the solder it comes back together, it dries out. So this is the last of the joints for the motors. Alright, so this is the wiring diagram that you need to follow, and please take a screenshot of this. Just keep in mind that all the TX goes into the RX, and now we have installed the FC on top of the ESC, and we are proceeding with soldering the peripherals. You might see something weird about this is that the XT60 is coming out of the front side and not from the back. The reason for this is we want our power cable to be as far away from the antennas to minimize the EMF things that could affect the signal that is being received in the antennas. So we have soldered the ELRS receiver, and right now we're soldering the GPS and the compass. We have it wired mounted in the back and wired to the right side, which is basically the left side of the FC, because it's mounted 180 degrees on the yaw axis. This we will change in the firmware later on. So this is the bad thing. This is something I do not like about connectors, is that you have to change the wires every time according to whatever your wiring diagram on the FC side is. So I'd just rather solder the wires. Right now I'm using a 25 watt soldering iron, which has a smaller tip than the big one that I was using earlier. Now we have the as you can see that due to the fact that the FC is mounted front side back, the camera wires are going to the back and the VTX wires are going to the front from the back. Yeah, that's the thing. I mean, like, not the VTX wires are going there because we haven't soldered them, but yeah, you can see that the GPS wires are going to the front end side of the FC. Reason being that it's mounted 180 degrees on the yaws, but trust me, it is completely worth it mounting like this. It makes the calibration and the tuning process extremely easier than what you would do with the standard practices. So for the VTX, we are not going to use any of the extra things. We'll be saving the UART of the VTX. We don't need smart audio. We will just put the VTX to a particular channel and let it be there for the rest of its life. Even though if you want to change it, you can press the buttons and do it. It's just too much of a hassle for me to do right now. I don't want to put it because, see, most of my quads are tuned to R8 and never have I ever had to change the channel. I have, I just don't get it. The whole point of smart audio is there. It is good. It needs to be there when you're flying with so many people. But honestly, do you have a lot of people that you fly with? I don't. So yeah, if you want to, you can use any of the UARTs on the VTX to put smart audio or ISC tramp, whichever your VTX is supporting. The AKK Race Ranger works on smart audio. I really like the fact that this ELRS receiver has a connector in between the wires, so you can unplug it and remove it when you're installing the peripherals. Because most of the times ELRS receivers do not have that kind of a facility. You are once soldered, you have to just remove the antennas and move around the peripherals, but for this it's quite easy. So this was me trying to find the heat shrink for the ELRS receiver, and yeah, it didn't work. It was too small. It was not this receiver's heat shrink. Alright, let's figure out what we gotta do with this telemetry radio. It has 6 wires instead of 4 that we typically have in our UARTs. So what we're going to do is we are going to carefully select the 4 wires from the pin out. What we want to use is the 5 volt, and we want to use the ground, the TX and the RX. The other 2 wires you can cut them out because they are basically clear to send and ready to send kind of wires, signal wires, which are used in the Pixhawk style telemetry and the Pixhawk style flight controllers, and yeah, so you can cut those off and wire those accordingly. The TX goes into the RX and the RX goes into the TX. This is actually not mentioned in the screenshot that we shared earlier, but just like any other peripherals, this is what you're gonna do. Really did not like the wires that came with this. They are not silicon coated, they are something else, the insulation. So it kept melting upon me when I was soldering the wire together. I mean this, but honestly speaking, this is not made for this. It's made for the connector, which only the Pixox style flight controllers have. It's always important to, whenever you have made a new solder joint, you check that it's not shorting by putting your multimeter into the continuity thing and touching both of the connections that you've made, and if it beeps, it means that it's a short circuit. So you want to make sure you do not have any short circuits whenever you're soldering a new peripheral. And I really recommend getting a very fine tip soldering iron for soldering on top of the FC, because you know these 65 watt and 25 watt soldering irons, the cheap ones, well, they come with a very thick tip, and the FC soldering pads are small and close to each other, and when you're trying to melt the solder on, you know, the tinned solder on the pad, it tends to melt the other pad as well, and the wires come loose. This is what I've been struggling with the big soldering iron. I did get a new one, small one, but yeah. Alright, so it's working, everything is working. You can see all the lights come on, the VTX has power, the ELRS has power, and the SICK radio had power. So I think we're good. Now we can, you know, wind up the build. Now that everything else is soldered, all the connections are fine, we have checked them, we have double checked them, we installed the battery using a Wi-Fi short saver, and so we're going to close the top deck of the quad and finish our build. This is coming together very nicely. Oh, I forgot to mention that to install these motors on these arms, it's really fine with the standard set of screws that you get, but if you're adding the arm supports that are on the sides, the standard screw is not long enough to reach the motor holes, so I had to order M3 by 10 mm spare screws online, and that's why you can see that they have a slightly different color from the rest of them. You can get these screws from only screws.in. Yeah. Always once you're done building a quad, make sure before you proceed any further, after you've closed the quad, make sure that you just check all the screws that if they're tight enough. Alright, let's jump to the mission planner. This is the part where we're going to set up the firmware. Okay, so the FC that we got from Darkmatter is already having ArduCopter pre-flashed in it, so we just need to configure it. I'll show you some basic things that need to be done. Everything else is pretty simple, and if you have any doubts, you can join the Darkmatter community and ask us over there. So for the frame type, the default option setup is on other, which is basically Betaflight X is the one that we have, that the Darkmatter guys have kept over for the ArduCopter build, because most of us are coming from FPV and we're used to the numbering of the motors like Betaflight does. So this is basically just the numbering of the motors, and like that the bottom right is the one, and top right is number 2, bottom left is number 3. That's what it is. So this is what difference the frame type makes when you're setting up a quad and mission planner. Okay, so what else you need to change is, give me a second. Okay, you can see the motor PWM_type is set to 5 or 6, which is D-Shot 300 and D-Shot 600 respectively. It's up to you to select whatever you feel comfortable with. So we are running D-Shot 300. I don't know why I'm running D-Shot 300. Right. In the initial tune parameters, A screw size in inch is the prop size that you're going to be using. We will be using 7 inches. and battery cell count is what battery you like the number of cells that you're using, and battery chemistry is lipo or lithium ion or lipo high. So this is basically, this sets the default values for fail-safe parameters and everything else. That's why you need to select the correct one. To calibrate the accelerometer, you press this button and then you have to rotate your quad into multiple positions and directions so that it calibrates the accelerometer. Then you calibrate the level. Next thing you need to calibrate is the compass. You go here, you select the compass that you're trying to calibrate, and since we're using an external compass and only one compass, we have removed the other checkboxes and just use compass 1 as checkbox. You start the button and it starts rotating, and you start rotating the quad and it calibrates itself. For the servo output, we have set motor 2 and servo 2 and servo 3 to reverse, which is the clockwise and counterclockwise look thing according to that frame type that we had selected. Serial ports, these are the serial ports that we are selecting. On UART1 we soldered the RX, on UART2 we had the GPS. For our SIG telemetry radio was on port number 3, which is UART6, and on port 4 we can put the smart audio, but we did not solder the wire, so we're not going to do that. ESC calibration, you do not need to calibrate the BL Heli ESCs, they are fine as it is. These are the flight modes that we put on our flight mode switch, which by default is RC6, but I have changed it to RC7. We will come back to that very soon. This is where you can set up your SIG radio, telemetry radio, if you are using it, in the SIG radio tab. Now we go to motor test. This is where you click the motor and the motor starts to spin. You need to make sure that number 1, 2, 3, 4 are according to the frame that you selected, and you need to see that the direction it is fine or not. And if you need to change the direction, this is how you check it. And to change the direction, you go back to the servo outputs and you check mark the reverse checkbox like I showed you earlier. Okay, the full parameter list is big, and this laptop is old, so it takes some time to load. Let me see what else. Okay, AHRS, we have changed something here. The AHRS orientation is at 4, which is yaw 180 degrees, which because we had mounted the stack front side back. In the arming check, you can set particular things that you want to ignore in the arming check. We are going to be using everything because this is an expensive build. We do not want anything to fail safe, so we want everything to be checked before we arm. What else is there? Why is the printer added? Alright, so RC channels. RC is the one that you're using, the protocol. RC_protocol 1 is ELRS that we're using, Crossfire. And RC1 is ailerons, which is your roll angle, which is the roll channel. RC2 is AE elevation, which is the pitch and things like that. So RC5 is the aux1. We have kept it for arming. The RC6, we removed the thing from RC6 and we put it to RC7, which also I think is saying 0, because this option is not in the RC1, it is in flight mode. Flight mode _ channel. You have to set the channel to 7 if you want to use that channel to change the flight mode. So my RC7 is a 3 switch channel, so that's why I've kept it there. RC8 I've kept as motor emergency stop, The reason being that in some autonomous or assisted modes, disarm is not really disarm. So it tries to disarm, land and disarm, but it doesn't always work so well. So in case you have to stop your quad in an emergency, you always have to set up an RC button to make sure that it happens. I think this is pretty much it. We've covered almost everything. You can go into setup, you go into the OSD, you can set up the OSD if you want. If you have your flight controller mounted in any other way, you can set it up in AHRS orientation. I think I'm missing something. Alright, so yes, since this is a freestyle build and we are setting it up for autonomous missions, it's a little bit too powerful to be able to loiter or alt hold very smoothly, so it oscillates in the Z axis. So to remove that, we had to change some values. As you can see, this PSC underscore ACC Z underscore I is changed to 0.3 and Z underscore P value is also changed to 0.2 instead of the default values of 1 and 0.5. This will sort out that issue if you're facing that issue. Now this was the frame class where we have selected bit of light X, which is value 12 and which is the default value that we have kept for our flight controller. I may or may not have skipped something in this video. If you feel any doubt, please, I request you to please join our community and ask away, because that's how we can grow together as FPV builders and pilots in India. Yeah. Alright, so let's plan the first mission that we're gonna do. We have set the home altitude as default altitude as 10. This is in meters, and we've kept the home location near the T junction near my house. And this is the first waypoint. You just have to click to set up a new waypoint, and then you click somewhere else. That's the next waypoint, then the next waypoint. It keeps adding into the list, as you can see. So in this you can see there's a column called delay. That is the number of seconds that your quad will stay there before it moves to the next waypoint. You can change a lot of things over here. You can change the altitude. As you can see, the altitude is set to 10. You can see in the next column. So yeah, this is then there's a delete button. There's arrows up and down, which is changing the waypoint order, that this comes first and then this one goes. So after that, we are going to right click here. We're going to click RTL. RTL is return to launch, or we can do loiter for a indefinite number of turns. So there's this we've kept 3 turns loiter, so it's gonna stay here and it's gonna rotate in that radius for 3 times. Then we have so this is how we set up the missions. You kept 3 loiter turns as waypoint number 7, and what else? Now we have RTL. So what it will do by default in RTL, it's going to come back to the home location and hover over there and start landing itself. Now you can save file and save it on your computer. This mission, if you're going somewhere, you can pre-plan a mission, save it in your computer. If you're doing multiple missions, you can make multiple files and save it on your computer, and then when you have to execute them, all you have to do is connect your FC or your drone through telemetry or through the USB cable, and you click on right button. So this is me changing the altitude because 10 meters was a little too low. It could crash into a tree or a pole, which we do not want. So we changed that, and now we're gonna save it again, and mission ArduCopter tutorial. Alright, and then you're going to write this and it will write the mission. You can click on read button to verify if it is working or not. Yeah, that's pretty much it, how you set up the autonomous mission, or how you set up the ArduCopter, or how you make the drone. I think we've covered everything. If you're facing any kind of difficulties, you can always count on us to help you out with this. Alright, thank you.